Hi, my name is David Johnson. I'm a researcher and software engineer at the University of Utah, and in this video I'm going to give a brief overview of the Powder platform. Powder is a platform and facility built to support wireless network research, experimentation, and testing, all the way from low-level physical radio work to massive MIMO, including end-to-end mobile and cloud use cases, including O-RAN. Powder is sponsored by the National Science Foundation as part of its Power program and by a large industry consortium via public-private partnership. At a high level, this slide shows the Powder radio and compute infrastructure and resources that are offered to experimenters. Starting in the middle, we've deployed stationary radios that can be thought of similarly to base stations in a cellular deployment. These are connected to edge compute resources via low-latency, high-capacity fiber front haul, and from there, over additional high-capacity fiber to a metro cloud facility in our downtown data center. And from there, out to the public internet so that they're remotely accessible. We also provide a controlled RF environment. Down at the bottom, our fixed mobile and portable endpoints each contain radios and compute resources as well. Fixed endpoints are stationary and attached to campus buildings. We've deployed nearly 20 mobile endpoints in campus shuttle buses to provide a little bit more predictable mobility. And we have a few portable endpoints that can be relocated for specific kinds of experiments. Powder is deployed in and around the University of Utah campus in Salt Lake City. You can browse to the URL shown on this slide to see the current availability of radio and compute hardware at each base station and endpoint, and live tracking mobile endpoint locations. We're also constructing a dense radio deployment on campus, think deployment on lampposts. You can find more detailed information on our website. The Powder platform is overall end-to-end software-defined. There are software-defined radios in the RAN, general-purpose edge compute and metro cloud facilities, and this design flexibly supports many kinds of research and allows users to bring their own software and configuration to customize their experiments. That said, not everyone will want to use our hardware, so we also offer a bring-your-own-device model where researchers can bring and plug in their own hardware at different locations in our deployment. I'll briefly touch on our model for creating experiments. We provide a real-world lab for experimentation, not a specific mobile wireless software or network deployment that is fixed. This means that users can compose hardware and software to create many kinds of deployments or networks with different software stacks, whether it's core radio work or end-to-end mobile cloud. We have what you can think of as a database of profiles, which are recipes that specify the hardware that the user wants, a network topology, software configuration, and runtime control scripts. Our control framework takes that recipe and instantiates it as an experiment, meaning that it allocates physical resources, connects them into the networks required, loads disk images and software onto them, and runs the user-provided scripts to customize further. Once that's done, the control framework gets out of your way. You have remote access to all the hardware, power control and reboot, and disk reimaging, serial consoles as available. Users can create these experiments through our web interfaces or through a remote API. To give you a flavor of some of the radio resources that we provide, we've included this small gallery of component diagrams and deployment photos, which I'll just go through very briefly. This is our base station architecture. It contains NI SDRs, N310s, and X310s. It's a climate-controlled cabinet that's deployed on building rooftops. Here are some photos of the antennas and cabinets at one of our deployed base station locations. Our massive MIMO base stations are supplied by Skylark Wireless, and software is provided by our partners at the Renew project, also another Power project. It has many small SDRs connected in transceiver chains for a total of 64 by 64. These photos show some of the transceivers and antenna elements, as well as the fully deployed antenna array and hub at one of our locations. Finally, this diagram shows our basic fixed and mobile endpoint design. It includes an NIB210 and N300 that are connected to a small but powerful compute node. Endpoints are typically backhauled over campus Wi-Fi and LTE, although we have some flexibility for the portable endpoint case to plug into wired backhaul if it's available where the portable endpoint is. Pictured here are a fixed endpoint mounted to the side of a building, a mobile endpoint in the back of a shuttle bus, and a partially assembled endpoint. In addition to significant hardware resources, we provide pre-packaged profiles for radio, mobile wireless, and cloud stacks and more to be used as building blocks for experimentation. Our general strategy is to use open source software as much as possible to facilitate modification for research purposes. These profiles provide both the software and configuration for many use cases: 4G, 5G, RAN or Core, ORAN and ONAP, or generally useful cloud software like Kubernetes or OpenStack. We attempt to expose useful configuration knobs as profile parameters so that users can easily point and click to customize, for instance, a Kubernetes deployment with the features that are necessary for their particular use cases. Users can extend these profiles or add their own. This has been a very brief overview of the Powder Wireless Network testbed and platform software. So for further information or to apply for an account, visit powderwireless.net. Thank you.